All right, I'm going to try and go through this as quick as I can, but still explain things as best I can. So we'll keep it brief, but hopefully you'll get a lot out of it. So first question, you have a negatively charged plastic comb that's brought close to, but does not touch a small piece of paper. If the comb and the paper are attracted, this is one of those tricky questions. So it's a negatively charged comb. If the piece of paper is attracted to you, your first guess is that it must be positively charged, but it doesn't have to be. It could be positive and negative, so it's neutral, but you get this charge separation and the positives are attracted to it. So just put a little more thought into it and don't just jump to the has to be positive. It could be positive or neutral. Next question. You have two neutral metal spheres. The fact that they're metal, on this question, that means they're conductors. So charge can flow between the two of them. It's on an insulated stand, so no charge is going to come from the ground. Negatively charged rod is brought near. What's going to happen is all of the negatives that are in A are going to try and get as far away as possible and congregate at B. That's going to leave a net positive charge behind. So how are the spheres charged? A is positive and B is negative. So the answer is D. If you separated them, they would stay that way. But if you leave them together and get rid of this, they would go back to being neutral on both of them. Diagram below shows two identical metal spheres. So the metal means conductors. The charge can move, but not from one to the next. Each sphere possesses a net charge of -3. So your first thought here should be the net charge is equal to -6 times 10 to the -6. If the spheres are brought into contact with each other, you still have a net charge of -6 times 10 to the -6. But remember, they're going to try and get as far away from each other as possible. In this case, I think it's just going to go back to the original way because that is sort of the equilibrium condition. So the answer for that would be -3. If one was -2 and one was -4, you'd still have a net of -6, but then they would split -3 and -3. All right, when a neutral sphere, metal sphere, is charged by contact. So the key here is contact. By a positively charged glass rod, the sphere becomes the same charge, so that sphere is going to be positive. The reason why it's going to be positive is negatives, electrons, are going to flow to the rod. So the reason why it becomes positive is it loses electrons. It does not gain protons. Protons don't move. All right, next question, number 5. An alpha particle consists of 2 protons and 2 neutrons. The alpha particle's charge of +2 elementary charges is equivalent to, so again, I told you it's not really an equation, it's a conversion, but the number of coulombs equals the number of elementary charges times 1.6 times 10 to the -19 coulombs per charge. So if you have 2 elementary charges, 2 times the 1.6 number is 3.2 times 10 to the -19. Not positive 19 over there. Next one, it uses the same idea. An object cannot have a charge of. So they give you all of these charges in coulombs. The idea is that the charge can be fractional. What can't be a fraction is this number of elementary charges. I can't have 1.5 elementary charges. I can have 1, 2, 3. I can have an integer number, so n times e if you want to call it that. So what you have to do on each of these is divide the number of coulombs by that elementary charge. So coulombs, which is what all the answers are, divided by 1.6, 10 to the -19, will tell you the number of elementary charges. Look at those and see which one isn't an integer, because it's saying which one cannot have. And I think the answer is 4.5 times 10 to the -19. Charge to mass ratio of an electron. This is just a reference table question. Charge to mass. So how much charge, Q, divided by mass? For an electron, 1.6 times 10 to the -19 is the charge, coulombs, and the mass is 9.11 times 10 to the -31 kilograms. If my math is right, I think I get 1.76 times 10 to the positive 11, because this divided by this ends up being a big positive number. And number 8 is similar to number 6. Which one could be found? Again, these numbers have to produce, in terms of the number of elementary charges, an integer. So you do the division, just like we did. I just erased it, but the number of coulombs divided by that 1.6 times 10 to the minus 19, 10 to the minus 19 number will give you the number of elementary charges. The first one is a half of an electron. The second one is 1.5 protons. The third one, I believe, I didn't check my math, but I think I did it before, is like 11.25. And the last one is 20 protons, or 20 positive elementary charges. So that's definitely possible. So D is the answer.